Welcome to week 3, telling stories and asking questions. And here again, it's our usual acknowledgement. So here's a rundown list of our week 3 activities. I want to briefly talk about the Python issues, which you should have done with your homework 1. And I want to talk about how you identify data problems that your visualization should tackle. But as I said many times before, creating effective visualizations is not just about creating beautiful pictures. It is more about telling stories and engage your audience. And next, I want to give you a brief introduction of Illustrator, the tool that will be used to add the final touches of our graphs for visualization. And then I'll briefly talk about assignments for next week. So our Python exercise was mostly to get you exposed to the idea of collecting data. And again, in the ideal world or in the perfect world, somebody else have already done the hard work and collect the data, clean the data so that you can just directly analyze and visualize the data. But in the practical world, sometimes, and actually many times, you might have to collect the data yourself using a scripting language like Python, especially if you're trying to scrape the certain websites. So what we did, what you have done hopefully in your assignment 1 is to finish the Python exercise, a revised version of the example in the book, in the Visualize This book. And what I wanted to remind you is that you need to double check the source of the site of your dataset, which is Underground Weather website. You need to make sure that you get the right component for the corresponding weather data that I request you to crawl or to scrape. Another tip or friendly reminder is you need to pay attention to how counting works in these scripting language like Python. So if you have an array, the first elements start with index 0, right? Whereas, for example, R, the index of the first element start with 1. So you just have to pay attention to these little nitty-gritty details when you write your code for Python or for R. And then I want to briefly talk about 2 interesting case studies. The first has to do with correlation and causation, or in other words, how do you detect patterns in your dataset? And this is a quite famous example. So this is John Snow, who is an English physicist, I believe, in the 1800s, and he's being widely regarded as the father of epidemiology. Forgive me if I didn't pronounce that word right. Basically, study the sort of the spread of contagious diseases. So in this example, John Snow was puzzled by the outbreak of cholera in 1854, and there were 83 death cases from this particular disease in London. And the question he was puzzled with was there a pattern to the outbreak? And really, the ultimate thing he wanted to find out is whether we can find out the cause of the outbreak, and whether the pattern will tell us anything about the cause of the outbreak, and then they could intervene and have interventions to hopefully decrease or stop the outbreak. And one of the hypotheses he had was, could the impurities in water be the cause of the outbreak? So what he did was quite novel. So this is a map of London, and you see here is he put this these little bars as clusters of disease cases of the outbreak on the map. So if we zoomed in, you see that these little bars, which represent the number of disease cases of the outbreak of the disease. And one thing to notice is that there is a water pump on the Broad Street in London, and many of the clusters are near this pump. So this got him to think whether that water pump was, the cause of the outbreak. And he basically suggested government to shut down this water pump. And the government did that. And after they shut down the water pump, the number of disease cases went down dramatically. So this is a great case of visualization, help people identify causes of important events, and in this case actually lead to saving many people's lives. Give you another example. So in this case, this is about universe. Again, I don't want to claim I know too much about physics. I suck in physics in school, in middle school. But in this case, it was a quite interesting case, right? So this is about expanding universe. So 2 facts about the universe. First, the universe is 93 billion light years across. So again, light years is a unit of distance. So it's really wide. 93 billion light years across. That's the width of the universe, if you will. But at the same time, the universe is only 13.75 million years old. And we know that from Einstein, that nothing can travel faster than light. So light is the fastest in the universe. And the question you would immediately come up with would be, how can the universe be 93 billion light years across if it's only 13.75 billion years old, right? I mean, nothing can travel faster than light. So what's going on? Well, first of all, here's a very nice visualization of the universe and its expansion. And there's a popular theory in physics, the Big Bang theory, where when the universe came to being, there's a Big Bang, and right after the Big Bang, the universe expanded exponentially, dramatically. So as it turned out, one of the popular theory to explain this interesting fact, why the universe is so much wider than its history, is that the space can actually expand it faster than speed. And the astronomers have came up with this nice visualization, this analogy. So they use the loaf, the rising loaves in a raisin bread, as the space-time, whereas the raisins in this bread as the objects or the galaxies. So you see that the loaves keep rising in this bread. So these are representing the expansion of the space itself. And anything within the space, be a baseball, a spaceship, or a photon, or a beetle, they cannot travel faster than light. So even though the speed of light limits how fast an object in the space can travel, like a beetle, it does not limit how quickly the bread or the space can rise. So under this theory, our universe is about, again, 14 billion years old, but due to the expansion of space, we human beings are observing objects that were originally much closer, but because the universe was expanding, we feel like these objects are considerably further away than the static, about 14 billion light years distance. So again, What I wanted, so this example is not really about physics. Again, I'm not a physics expert. This example was really about this visual metaphor, this visual representation, this raisin bread that tries to illustrate the theory. Again, the astronomers has adopted this visualization to help people, the ordinary citizens, understand this, the science behind this theory. Okay, very nice examples of illustrating how visualization can help you identify patterns and relationships. Now, how do you identify data problems? Well, we kind of talked about this in last week's lecture, right? There are 4 ways. One is hypothesis testing. You come up with some hypothesis, and then you're going to test it. You can also look for exceptions or outliers. And the third way you could do is to try to minimize the uncertainties, to maximize likelihood of things that you want to see. So again, this will help you make better informed decisions. And lastly, hopefully, the data problems, by answering the data problems, it will clarify things in your data set. Again, there are many things you will be interested in, many domains. You could use the same process to identify data problems. One last bit about data question. Okay, it's great to come up with or articulate your data question that your visualization should answer. But an equally, if not more important aspect of this is to articulate the audience of your visualization, right? So you need to identify, so who's going to read or see, review my visualization? Who cares? Is it the students? Is it, astronomers? Is it ordinary citizens? Or is it, your coworkers or your managers? So depending on the audience, the way you present your visualization would be different. And this should be pretty straightforward. Right? Because different people have different backgrounds, have different experiences, different skill sets, different knowledge set, right? So you want to cater your visualization to your audience. Right? When you trying to come up with your data questions, you want to keep in mind the following things. First, what they do not know. Right? Ideally, your visualization should uncover things that's kind of hidden in the data set, that just by eyeballing the data set itself, it's hard to immediately perceive that pattern or insight. So that's something you want your visualization to help convey. So what they don't know already. And next, why does it matter? Because if that doesn't matter, then why are you spending effort and time to visualize this? You're wasting everybody's time, right? It has to be something that's important. And lastly, depending on what they don't know and why it does not matter, it should tell you something about the way you present your visualization. Maybe you wanted to present in certain format, be it a scatter plot, using points to dots to represent your data, or you're using a bar chart to represent the time series data. So it depends on the nature of the question. You will have to pick a good representation of your data set in your visualization.